Hey, there it is. Okay. So quickly, Ricardo. Yeah, he's a great programmer and speaker from Chihuahua, Mexico, and he solved a great mystery of life: how to sneak Elixir into a Java server farm on a Raspberry Pi in the corner. Give it up.
Thank you. Also, my name is Ricardo Echavarria, but you can call me Richie. I work for Grain, which is a company in San Francisco, and we basically turn your video calls into highlight reels or clips of the most important things that's said in a given video. I'm from Chihuahua, Mexico, and I know you're going to ask, so I'm going to tell you that yes, there is a Chihuahua in Chihuahua, Mexico downtown. There are not a lot of them. I guess they are from there. I really don't know. So, the first thing I want to talk about is WebAssembly. And I really like WebAssembly because I believe that it's not web, and it's also not assembly. But I really like it, so that's what the name they chose, and that's fine. So what WebAssembly is, it's a binary format and a stack-based virtual machine. So that's what it really is. And so what this means is that you can have a set of instructions. And what WebAssembly will do is give this instruction a format, and then the virtual machine will understand. And you might ask, why don't use? I mean, we have a lot of virtual machines. We have the Java virtual machine, and .NET is also a virtual machine, and of course the Vim, we have that, right? Why don't we use some of the existing virtual machines? And one of the reasons is that this virtual machine is optimized for some of the things that will happen in the web. So they have a point there, more or less. And one of the things you can do is that once you're transmitting a file, and once it's receiving it, the runtime can actually start compiling it as it's receiving it. So by the time the network is done transferring the file, it might already be done compiling. So that's great. And the other reason why this is great is that if you ever written JavaScript, you might not want to write JavaScript anymore. I do like JavaScript. I had to learn to love it. So there's a lot of momentum going for web applications, and there are these progressive web applications. And one of the things that sometimes you cannot do, if you already have a project, a big project from years and years, is to translate everything to JavaScript so that it can work on the browser. So this is the use case I like the most, is when you can reuse some of the stuff you already made in the past, and you can compile it to WebAssembly, and in that way the browser will run it. And one of the examples I like is this company called AutoCAD, and they have a CAD system for doing blueprints and all this stuff. And they have had like 20 years of code that they have written, and they tried, the first thing they did was try to move all those code to JavaScript, but it was very difficult. So when WebAssembly came out, they started using their actual code that has been written in the past 20 years, and they could use it in the browser. So that's how they actually put together their web version. So that I find that pretty cool. There are some other people that are doing video encoding. Machine learning is also one of the things they are using it. And so some of the people are focusing on the performance part, but I do really like the reuse part. And well, if you go to the WebAssembly website, you will find that it says that it's a binary instruction format, right? And one of the things I noticed is that it says it's a target compilation for C, C++, Rust, and that kind of languages. And I don't see Elixir there. So that was kind of disappointing. And this is where Lumen comes into place. So Lumen was presented, I think, 7 weeks ago in ElixirConf in Denver, and I was super excited because I've been studying WebAssembly for this past year, 2019, and one of the things I didn't like is that I don't get to play with Elixir if I'm doing something in WebAssembly. And so that's exactly what Lumen is trying to do. So if I just told you that you can use C or C++ and compile it to WebAssembly, right, instead of compiling it to binary, probably x86 code, and we have the bean, and the bean is basically made in C. So we could potentially compile the bean to WebAssembly and then run it on the browser. That sounds like a good idea at first. So why don't they didn't do that? Well, first, the bean is a big project. So if you try to do that, and they try doing an example when they compile one library that is used a lot, and I think that was like 3 megabytes once compiled into bean files. And the whole project, it was like 10 megabytes. And if you include the bean, that's probably 40 megabytes. So it will be super fun to be on a web page that you have to download 40 megabytes just to see it running. So that might not be a good idea. And the other thing is performance. So WebAssembly is a virtual machine, and the bean is a virtual machine. So if you compile it to WebAssembly, then you'll have WebAssembly running a virtual machine, which is bean, and then bean running your code. So that might not be a good idea. There are some performances optimizations that WebAssembly do, but that will be only for the bean part. But it won't go all the way to your project because you always have 2 layers. So that doesn't sound like a good idea. And the third reason is a concurrency model. The bean doesn't care. Any of the processes in the US is not special. But in the browser, one is very special. So this is how bean sees processes. All of them are the same, we don't care. But Lumen has to take into account that one of them is the UI. Have you been to a web page that is very slow when you click a button? They're using the UI thread probably. So when you are doing work in the UI process in the browser, you're actually blocking everything until that work is done. And so to do all the other work, there's a model to use web workers, and that's what they needed to do. And so it wasn't a good idea to compile the bean as is. Of course, they could have just changed the bean to have one process that is special and that you assign the least amount of time to run in that thread, but that would require a lot of work. The bean is a big project, so they didn't go with that. And so they did 2 things. One is to do a compiler. So that means when you do a Lumen application and you want to compile it to WebAssembly, you are actually not compiling to the bean. You are compiling all the way to WebAssembly, to this binary format that is WebAssembly. And so it has several parts. It's built with LLVM, which is a set of tools to make compilers and runtimes, and it's written in Rust. Anybody here doesn't know what Rust is? Okay, yeah, so it's a language for that is memory safe, basically, that's the goal. And it's a competitor, probably, of C++ or an alternative. And also they use a Wasm Engine project, which is a way to combine Rust applications and combine them with JavaScript so they can run in the browser. And so it's pretty cool. It has 3 steps. So you actually write Erlang or Elixir, and it compiles. You can compile them to Beam, or you can leave them as Erlang applications. And then it will turn these files into an intermediate representation called EAR. That's Erlang Intermediate Representation. Then it turns that into LLVM, intermediate representation, and finally it turns that into either, since it's a compiler, you can either compile it to native x86 or WebAssembly code. So it takes several steps to actually do that, which I find very interesting because I don't know anything about compilers. And if you're part of the team, feel free to say that everything I said is wrong. And they also build a runtime instead of a virtual machine. So when you're running your Elixir code in WebAssembly, you have, well, when you're writing Elixir, it doesn't matter where, you already have a set of functions that you use. So this is where the runtime comes into place. What they did is they figured out memory management, because memory management in WebAssembly is very different than memory management in other architectures. They had to do the scheduler again, because of, we saw not all the processes are the same, so you have to take that into account. And they included what they call binary included functions. So for example, map.toList, that's an included function. You don't write it, you just use it when you're writing Elixir. And they have a whole list of all the included functions that the bin has. So they have to rewrite it, basically. And they made a demo, which I really liked. The demo is, it's in the programming Elixir book. It's called the spawn chain exercise. So what it basically is happening is you have one process, and well, you give the function a number, and then you have one process start with 1, and that process will add 1, start a new process, and then the second process will receive 2, and then it adds 1, that one starts another process, all the way until you get to the number that you gave the function. And once it's done, it will return to the first process. So when you execute this, you're actually creating a bunch of processes that would just only add 1. But it's really a good example of what the bin can do, because it's yeah, it's really good at processes, right? So that's the exercise that went with in ElixirConf, and I was very excited. And it works, you can run it, and this is what it's doing. It has 2 ways in their demo. They have 2 ways of showing you the result. One of them, it will just log to the console, so you have to look into the developer tools to see that. And the other one will actually output directly to the DOM, which is very interesting because WebAssembly doesn't actually have a way to write into the DOM. So they are writing a bunch of libraries to manage this interchange that has been done between WebAssembly and JavaScript, so that JavaScript can write. And JavaScript is the one that has access to the DOM. These might change in the future. I know that newer versions of WebAssembly at some point will have access to DOM directly, but it's, they will still need a framework to do that. So this is very cool. So after ElixirConf, I was super excited to see how it was. And one of the things I did is I downloaded the project, I started compiling it, and you need to compile LLVM for now. I don't know when this won't be a requirement yet, but you know, just I have free time, let's compile it. So LLVM says in their webpage, and this is where I took this from, that it's probably about 1 to 3 gigabytes, and if you're compiling more components, it can go all the way up to 20. So that's fine. I have a 256 gigabyte machine, so I just left it there. But it wasn't enough. I ran out of this. So if you want to compile it, you'll need at least 160 gigabytes free just for LLVM. So take that into account. So what I did was I bought an external disk. Yes. But external disk is a little slow, so compiling stuff in the external disk takes a long time. And it really was a long time. I just left it there. You know, I got married. You can do a lot of things while it's compiling. And finally, it will be over. You will have an executable that will compile your stuff. Yay! But not really. Once you compile everything and then you compile Lumen, you will have a set of tools. You will be actually compiling the runtime, and you can run the examples. But one of the things I noticed is that the examples didn't change when I changed the Elixir code. And that's because that's not done yet. So the examples that they have, all the work of the compiler is being done in another branch, and that's coming. I talked to the team, and that's coming. So right now, if you compile it, you will have your executable, and it will tell you like, hey, you can compile. But as soon as you give it all the arguments that the binary wants, it will say unsupported operation. Yay! So. And if you go to Lumen website, this is what it says. So I should have done that first, but I didn't. So what are the future plans they have? I talked to the team after doing everything, all of this. I should have done it before. Well, they are still working on some binary included functions. They are also working in an interpreter that is almost done, and the compiler that anyone can use will come in the coming weeks. They also are looking for help if you are doing a Hacktoberfest. You can be in contact with them, and Luke offered to pair with someone if you find Rust. I mean, if you're from the Elixir community, you might not find Rust easy. He offered to pair with someone to work on Lumen, if anyone wanted. Also, one of the things that team is figuring out is the use case, because right now they are thinking on using it as a web framework. If you ever work with LiveView, one of the things that makes this project different is that LiveView, everything is happening on the server. So there's no way to do that offline. But with Lumen, this is happening in the browser, so you could actually make applications that will work offline, or they might use the resources in the computer in a more efficient way instead of doing it through the server. So it's a different case, but still they think that the use case is web as a web framework. And they don't actually know how that will look. Should that look like LiveView, maybe? Or maybe it will look like something else. So they are figuring this stuff at the time. And this is where I get crazy ideas. So there's a new standard called WebAssembly Standard Interface. And what this project is trying to do is have a set of instructions or rules to actually run WebAssembly everywhere. It doesn't mean you don't need to run it on the browser. So I find that very interesting, because I think that WebAssembly, that's why I don't see why they call it WebAssembly, begins to have problems. So you can run WebAssembly on a server. There are some services like Cloudflare who offer to run WebAssembly code, or they call it on the edge. So there's a lot of things you can do with WebAssembly. You can even run it on your computer as a command line tools. So I think in the future, the first step to install Elixir will be just install it in the browser. Don't ask for the administrator of the high school you're giving classes for laptops that will come 2 weeks later. Just go to our web page. You know, it will have the editor. You can just install it with a single command, and it will be actually installed in your laptop, so you don't have to rent servers. There's a lot of services right now that actually take your code, they go to a server, they run your code, they come back with a result. that won't be the case. This will be running in your machine already, and this will be thanks to Lumen. So all those kinds of things, I think will be amazing. And actually, I think at some point, maybe, Lumen will be the most popular LLVM. You might be able to run, so you can compile, you will be able to compile your code through Lumen to WebAssembly and use it in your Ruby application. That very slow part, don't worry, just call WebAssembly. There are already tools to call WebAssembly binaries from Ruby, Go, Python. So this can be a universal binary format that you can use all over the place, and maybe that will make Lumen so much useful that you can have processes and everything you need in Elixir and use it in other projects. Maybe to deploy, you don't need to do this huge Docker file that you're already doing that takes about 30 minutes to build. You can just compile directly to WebAssembly and deploy it to the server or to a bunch of servers, to a Lambda service kind of thing. So I'm really excited for WebAssembly and the Lumen project. I really find it very interesting. If you download the code and you go through all that I did and you think it wasn't worth it, I definitely say that it was. You can see the Rust code that it's generating. And it's very interesting how they solve a lot of the issues, because Rust and WebAssembly are not actually runtimes that take into account processes as the Vim does, which is like a native thing of the Vim. So the way they solve this, to be able to have a lot of processes with just one thread in the browser, is very, very interesting. And I'm pretty excited. Actually, I want to try to pair with Luke next week. Hopefully he accepts me. And yeah, I'm not part of the Lumen team at all. I'm just an excited person about WebAssembly. Yeah. Y muchas gracias.